So today we'll spend a little time, and I think there might be some time for a second TED Talk at the end to make up for that day that I didn't. How did I not show you on that day? What were we doing? Remember? Okay. Anyways, today we're going to talk about Bohr models, Lewis dot diagrams, and ions. Okay, so a little bit of quick review there. I think you got it on the sheet, and I don't have an extra one, so I'm not sure. Do you have to write this down? Oh, no, am I making it easier on you? So the atomic number is the number of protons and the number of electrons. Now, I noticed a few people used the plus sign for and there, but you got to be careful, okay, in this situation, because it's the number of protons as well as the number of electrons. So in other words, like, you know, like fluorine is number 9, that means it's got 9 protons and 9 electrons. It doesn't mean that when you add them up together, you get 9, okay? And electrons are drawn in shells. You guys have probably seen those shells before, right? This is kind of review. And those shells contain 2, 8, 8, and 8 electrons. And side note, that's a big lie. You take grade 12 chemistry, they'll explain a little bit more in detail. But for now, all you really need to know is that the first shell contains 2, and then after that, they contain 8. Okay, so let's do one practice one. I think this was one of the questions on that kind of grade 9 review. So let's just practice here with our good friend nitrogen. So we're going to draw a nucleus in the center. You guys have some room to draw this, right? Okay. So nitrogen from your periodic table is number 7, right, Chloe? So that means there's 7 protons. And it has an atomic mass of 14.01, so we'll round that down to 14. 14 minus 7 would give us 7 neutrons as well, right? 7 plus 7 gives us the 14. Okay, but what really matters is the electrons. So we got just as many electrons as we do protons, 7 electrons, and so they're going to go in these shells, 1 and 2. 2 in the first. Because we got 7, and we've used up 2, now we're going to put 5, right? And the ones after this tend to pair up. So 1, 2, 3, 4, 5, and then there's a single one all down here by itself. Hey, that's pretty easy, right? Drawing that way is kind of a bit of a waste of time, isn't it? Yeah, which is why I only gave you 6. I didn't spend a whole lot on it. These are called shell diagrams, and they're way faster, and do they show just as much information? They sure do, right? So, you know what? How about just pick one that you just did, and just draw one of these to remind yourself how to do it this way. You want to do that? Just pick one. I'll do nitrogen here. So you would just go N, and then you just go like 2, and this one here would be a 5, right? Yeah. And you know what? It's a whole lot easier to mark too, because when you do them with the circles, guess what I have to do? I got to count them all. Oh. Yeah, I agree. Way more sense. There's the inventor. Certain irony that his name is Bohr. I'm sure he's a smart man. I'm sure he was a lovely man. But yeah, kind of boring, right? What element is this? If I didn't show you this, if I just did this, you would have to actually count. Nobody wants to do that. Well, there's 20 protons, 20 electrons. That's actually calcium. Calcium. But yeah, they're hard to draw. Lots of unnecessary details. Kind of a bit of a waste of time. So these are referred to as shell diagrams. You can go ahead and use those. But there's an even better one, and that's known as Lewis dot diagrams. Okay, and I think that's what's next on your page there, right? On that first one? Is it on the back side? On the back side. Now, have you guys seen Lewis dot diagrams before yet? No? What? Okay, so some of you may have, depending on who you have, I guess, for grade 9. So they're named after this guy, Gilbert N. Lewis, Lewis dot diagrams, sometimes called electron dot diagrams. So what do? They simplify the drawing, and they only draw the valence shell. And when I say the valence shell, what does that mean? The last one, the outer shell. And what is so important about that outer shell? Yeah, it has electrons, and so do the other ones. What's the deal with the valence shell? Logan, you know? Don't know? Okay, well, it's the electrons in the valence shell that actually do anything. The rest of these ones inside here, they're just kind of hanging around. They're not really doing a whole lot. Okay? So only the valence shell ones are important. So this great big giant thing simply becomes this. Okay? You write the name of the symbol, and then you draw how many dots there are in the outer shell. And you can draw them with circles like that. You can draw them with colored in ones. You can draw them with just X's too, which are easy to draw too. Okay, so you only really need to draw those outer shell electrons. And this works because only the valence electrons are involved in bonding, covalent ionic bonding, which we're going to get into later in the week. And the inner shells are full and happy, and they have no interest in leaving the electrons. They are good where they are. Okay, so guess what we're going to do now? We're going to draw some, I think. Yeah, so I will get this one out. Okay, so can we talk a little bit about ions? Now, before I tell you that, can I tell you a funny story? Well, I think it's funny, you tell me. So I got this friend, he's same age as me, we graduated together. He had children really early in life, like November after we graduated. Anyways, he had two little boys, two or three? Two, right? So I remember his mother told me once that the younger one, she told the younger one, or told the older one to keep your eye on your brother. That's what I think of it, this eye on. She said, keep your eye on your brother. She had to run upstairs for a second, right? He was like 4 or 5, right? So all of a sudden she leaves the room and she hears this screaming and yelling, and she comes back and what's going on? And the older one's got his face right up against him. Keeping his eye on him. Like that? Is that funny? Yeah. It's a good story. All right. So in this sense here, though, an ion is simply, do you guys have this, or do you have to write this down? What do you have there on the back? Do you have this? Okay. So an ion is simply an atom that is either taken in or given off electrons to make the outer shell full. So it either gives them away, and then the next inner shell becomes the outer one, and it's full, or it takes some in and it fills up that space. Okay, so that's what an ion is. So for example, let's just look at one here, magnesium. You guys probably need to write this down, I'm thinking, right? Okay, so let's just look at magnesium here, okay? Magnesium is number 12, right there, right? It has 12 protons, 12 electrons. I'm going to draw a Bohr diagram because they make me smile. I don't know how many neutrons, doesn't really matter. 1, 2, 3, 4, 6, 7, 8, 10. Okay. You don't have to draw it. I'm just drawing it so I can explain it. So there's magnesium. It's got... Did I put 2 in the outer shell? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, what can I do? There's the 2. There's the 2 in the inner shell. So 2, 4, 6, 8, 10. It's got 12, right? So how many valence electrons does it have? 2. It's got 2 in its outer shell. It's unhappy. It's got too many or not enough in its outer shell. Now, it's easier to give 2 away than it is to bring in 6 for reasons that I won't go into. It's just simpler. Okay? So these 2 electrons would like to go away. And then which one becomes the outer shell? This red one full of 8, and it would be full, right? And I've kind of got that down here, right? So and I drew it with shell diagrams. So Mg is a 12. It's got 2 in the inner shell, 8 in the next, and 2 in the next. Right? I'm just going to go like this. Cover that up. Okay, so you should draw this down here. 2, 8, 2 adds up to 12. it would like to get rid of those guys. Get them out of here. Okay, so if you gave away those electrons, what would happen? Then you'd have 2 and 8, right? And this guy would be happy. This shell would be happy. It's got 8 in its outer shell. But there's kind of an issue, kind of a problem. If it's an atomic number of 12, that means it's got 12 protons. And I don't know if I've made that big enough for you to see, so I'm going to make it bigger. Right? It's got 12 protons here. After it gives away electrons, does it still have 12 protons? It does. So it has 12 positive charges, but now it only has 10 negative charges. And just like in junior high, middle school, when you've got plus 12 and minus 10, you have an overall charge, you have an overall value of plus 2. Okay? And that, my friends, is an ion. Now we have 12 positives and only 10 negatives, and so we have a charge of plus 2, an overall ionic charge of plus 2. Does that make sense? Brandon, am I making sense? Yeah, okay. Ruben, yeah, making sense? Okay. Okay, so now let me just make that a bit smaller. Okay, so this creates what we call a stable ion. It has a full outer shell and a charge of plus 2 because it now has 2 more protons and electrons. It has 12 protons and electrons. And we tend to write it like this, 2 plus. We don't write it with the plus 2. We'll say plus 2, but we write it 2 plus. Stupid science. Okay, do you guys know this already from grade 9? Have you seen this kind of thing before? Logan? No? Maybe not? Okay. So what would its Lewis diagram look like? Well, now the next shell in, right? So it would actually show 8 full outer shell, and it would have a charge of 2 plus, just like that. Last one. I need a lesson on photocopy. Yeah. That's not photocopiers. That's just, pushing buttons. Okay, so that's what the Lewis diagram looks like. You should now be able to work on those 2 there. I'd actually like you to hand those in to me, so I can give you a little mark for those. I won't take long to mark them. I do want to point out a couple things there. I don't have them. I've ordered this. I didn't make them. Okay, so the front page is pretty easy. You got the symbol, the family. I just want you to put the group number, okay? So 1, 2, 3, 4, 5, 6, 7, or 8, just the group number. I like that diagram. You guys can do that easy. Flip the page over. So you see the title. Funny stuff, man. Okay, so sulfur asks nearest noble gas. So the one way you can figure this out is if sulfur is, I don't have a stick. Sulfur is there number 16. The nearest noble gas is argon, so it needs to gain 2 electrons to get there, right? It needs to gain 2 to go to 18. Okay, which means its charge, if it's going to gain 2 electrons, it would have to be a minus 2. So when you gain electrons, you are negative. We should write this down. This is important. I'm going to type it so you can read it. This you might want to jot down. Gain electrons. You become negative. And if you give off electrons, then you become what? Positive. That's kind of the rule. Okay, I'll come around and I'll help. If I'd like it if you can, by the end of the period, you got till 11:18, you got like 18 minutes. Can you get it done in 18 minutes? I think so.